So, hello everyone, and today we will talk about Python, what's Python memory, because sometimes we start our application, but after some period of time we started to have problems, and we don't know why we have these problems, and maybe today we will able to answer some of our questions. But before it, I would like to introduce myself. I'm Yullia Barabash. Originally, I'm from Ukraine. Right now, I live in Munich. I'm cloud engineer and working at NordCloud. And my role involves a lot of different stuff. It means that from creating application by using Python to create cloud architecture by using AWS services. It means that I need to remember a lot of stuff. I need to remember some tricks of the Python. I need to remember some limits of different AWS services. I need to remember as well somehow services edge cases. But here's the twist. I'm bad at memorizing stuff. For me, to memorize something learned by heart is super hard, especially languages. That's why I prefer to understand stuff and remember why it's happening. And today we will talk about performance and try to understand what is performance. What is performance and how it's related to our Python. But before it, I would like to introduce Bob. Bob, he is a nice guy, he is athlete, and also he exercises every day to achieve his goals. But sometimes he has some problems. He fails his performance. And different factors can influence his performance. For example, he didn't get enough sleep because he was worried about his exam. He upset because of the weather or something bad happened that he cannot control. Or maybe he doesn't stick to his diet that also can influence his performance. So we can see that during performance, when we talk about performance, there's a lot of different factors that can influence our performance. For especially even this weather influenced my performance. But yeah. When we talk about performance, there's a lot of stuff we need to consider for performance. The same with the Python. Because Python lives in our machine, and we don't need to only think about the code of the lines that executed by Python, but also line of the code, but also we need to think about hardware and a virtual environment where Python executed. By environment, I mean our computers, our laptops, our EC2 instances, and other stuff. That's why we need to talk about the components of our hardware. Maybe somebody here knows what I will be mentioned, which components are important for our performance. Okay, we can, no? What? Yeah, one of them. Yeah, it's one of them, but it's true. Mine was almost everything, but well, let's check it together. So, what I will talk about its computing units. It's basically what is mentioned, our CPU, and memory as well. RAM, it's one of them, there's more, and basically connection between them, how we transfer our data between different these units. And if we will talk more precisely about computing units, we will realize that computing units basically are responsible for execution of our operations. It's responsible for processing of our data, and also it's responsible for example, executing mathematical operations. And performance of our CPU can influence by different factors. For example, number of machine code instructions that we are going to execute. Why I mention machine code instruction? Because Python is high-level programming language, and it was written for us human. CPU doesn't understand Python. That's why we have compiler and interpreter in place, which will transform our Python code in machine code, and this machine code will be fitted to CPU. And the number of instructions of this machine code will be executed by CPU is considered for our performance. Additionally, as CPU can be different. Architecture can be also different. Newer CPU can execute your instructions faster. That's why also to consider how many instructions per second our CPU can consider. There's some examples of computing units is basically CPU or GPU. Good example GPU, because right now we use GPU for machine learning. Because it can faster execute instruction, also because of the architecture, and we faster can train our model. Another important factor is memory units. It's where we store our data and store our information. Here, a good example of it, hard disk drive, solid state drive, cache L1, L2, in random access memory, RAM, that was mentioned. And this is also important because Python interacts with them, we will discuss later, and this type of the memory has different architectures, have different read and write speed that also can influence our performance, and it's very important to consider for our also environment. And if we will dive deeper on each of them, we can see that hard disk drive, basically, or solid state drive, they have similar purpose. They use for long-term storage. Python use it for storing files that we want to reuse across, even when your machine off, you want to reuse, for example, some configuration, you want to save your configurations. Also, you want keep, for example, data for users, or also files with Python code. One small note that solid-state drive has better performance than a hard disk drive. So if you have a lot of read-write operations, maybe you need to consider a solid-state drive because Python does writing to the memory. What is another is important that anyway, even solid-state drive is better in the performance that a hard disk drive is still lower than write and read operation compared to RAM. Another important factor is RAM. It's random access memory that Python also uses. It's basically responsible for short-term memory. And it stores our data and objects that are currently used by program. What I mean that in case we execute our Python code, and inside our Python code we have different objects, and all these objects stored inside the RAM. RAM has special place for it. It's called like Python private heap space. And during execution our Python code, interpreter will get some data from there and use for operations, and will pass to CPU and use for operations. Another one important is cache L1, L2, because it's also it was the smallest one, part of the memory, and one of the fastest one as type of memory. It's located very close to CPU, and is basically used for hashing. All operations that are executing going through the cache L1, L2, and one of the things that Python or internally machine can cache some of the Python operations, so it also will influence our performance by caching some most often Python operations. Some libraries, for example, NumPy, use this advantage for speed up calculations. Cool, so we have a look on the three types of the memory. And we understand that sometimes directly or indirectly Python interacts with it. And it's a lot of stuff how Python interacts with it. That's why I have like abstraction layer, because we're not going to go down into it. We just know there's abstraction layers that implemented in C that help to access like memory and manage memory. What we will focus today is basically on our RAM, and also about this heap space where we keep all the objects of our Python code inside the code. So what's basically Python private heap space? It's basically part of the memory inside the RAM that's managed by Python. Only Python has access to it, and Python keeps its objects inside. Why I mentioned objects so often? Because Python have functionality implemented in that way that everything is object. Your class, your function, your integer, your bullet, everything is object. Your data structures as well, list, set, dictionaries. In this, heap space is managed by memory manager. So if we have, again, on our part, we will understand that abstraction layer between Python and RAM is basically memory manager. So memory manager will take care of our heap private space inside our RAM, so we don't need to worry. And one of the responsibilities of it is basically to manage our private heap space inside the RAM. Also it has functionality to allocate and free objects, depends on the state of the application, which we'll also talk about. And also garbage collector is part of it. So memory manager does a great job and take from us a big responsibility because we don't need to think about the objects, about the memory and how it's stored inside the Python. We just need to keep in the mind that sometimes what we write make difference. And let's recap what we talk about, because we talk about a lot of stuff and it's good to recall it. So if I mentioned before that performance also depends on the environment where you execute. Main components is computing units, memory units, and communication between them. Type of the memory that Python interact directly or indirectly is basically hard disk drive, solid state drive. Also random access memory cache L1, L2, and all objects are stored in private heap space, and private heap space basically managed by memory manager. But stop. How memory managers knows what to do? For this, we need to have a look inside our Python. What actually going inside the Python? Because we were talking about what's going outside the Python. Let's talk about inside the Python. As I mentioned before, everything is object. Your code, functions, nar, integer, everything is the objects. That's why sometimes you can see that some people, when they create the function, they can reassign the function to another variable and later use this variable to call these functions. Because the name of the functions is basically references to actually object in the memory. That's why it's possible to assign our function to another variables because it contains basically the references. And if we have a look how it's basically our object stores, it basically keeps the value. It has three fields: file, type, reference, count. And basically it's a representation of the object in the private heap memory, private heap space. And where, for example, here we have the object of integer 3, we have value of 3, we have type int, and also we have reference count 1 because there are some variables that reference to it. And when we execute Python, all these objects create during execution. Another important factor is basically variables, because variables is actually just reference to our memory. It's very hard to remember address inside the memory because if you check, it's just numbers. And that's why we have nice variables that we can remember and reuse across our call and can speed up our performance. And that's why basically variables is just names or labels that actually point us to the object inside the memory. And if we have a look here again on our small example, what is actually happening when we execute code of lines, we can see that during assigning of 3 to A, what Python does, Python interpreter does is creates the object inside our private heap space. It will have value 3, type in, and references 1 because something is referenced to our object. With next line of code, when we create when we assign number 6, it will create a new object with value 6, type in, and reference count 1. You can see that we don't change the previous object. We just create a new object and cite reference to the new object, increment reference count to 1, and for the old object, we decrement value to 0, because nothing points to our object, and from this moment, it will just reference to the 0. It's basically what will happen inside the Python. But stop again. In this case, if we just create the new objects and we don't have, if we keep still all objects in some point of time, it will give a lot of errors. Our application crash. It will be super expensive to run our application. That's why we need, again, to talk what's happening exactly to our old objects. And for this, we need, again, have a look in our objects. As you can see that we have value. We know it's the value of our object. We know the in to know how we interact with this value. But also we have reference counter. And it's a very important thing because it's basically how Python understands how to manage objects. It has two strategy. First of all, it's reference counting, where we count references to all our objects. Depend on the state of your application, it can be incremented or decremented. For example, when you assign a new variable, it gets incremented because more variable assigned to it. When you assign your variable to a new value, your value gets decremented because it associates it with a new object, and old object doesn't have new previous association. And it's very important because some point of the time, this reference counter will reach 0. It means that nothing reference to our object, and Python understands we can get rid of it. That's why I have a garbage collection. And basically the logic of the garbage collection that it runs depends on the number of your operations that can remove it. And so we have this nice garbage collector that can clean up our space, free our space for further execution, and it also optimizes our memory. The thing is that we can trigger it manually as well via using of one of the module, GC, or also we can set up the threshold where it can be triggered. And basically, it's how Python manage objects. And if we have, again, example, have a look in our example, we will see that our old object will be removed. After that, garbage collector will check all objects because he will notice that reference counts will be 0, and it means that nothing is using our previous object and will be removed. Great, and now let's recap what we were talking about today. So when you are working with Python, think about your environment, think about your operations, and also think what kind of operation you will execute. For example, if you have a lot of read-writes, you need to think about your memory and how you want to optimize it. It's basically connected to hardware. Also remember, everything is object inside Python. It means that if you have some part of the code that it's part of the code, it stays there, it not influence my memory, it's not reachable by any code, it will not bring me some problems. At some point, it also will influence your memory because when Python compiles your code, it transfers all functions to the objects, and these objects will keep inside the RAM, so it can be called during executions. All objects are stored in private heap space. Also, private heap space is managed by memory manager, and it's responsible for it. And Python used two strategies to keep track of the object. It's basically reference counting and a garbage collection. And one of the references that I would like to recommend you to use to check is basically memory management in the Python. See Python internals, guide to the Python 3, high performance Python, and also talks that will be today after this session, immortal objects, and another talk that you can check online about the pointers because it's also connected that sometimes you can have you can lock your objects, it will not removed, and it also can cause you some problems in the futures. And it was everything from my side. Thank you for your attention. And do you have some questions?
Okay, there are some questions in Slido. I want to read it out. What is Python's abstraction layer for L1, L2 case?
Can I check? So basically, it's not like directly reachable from Python. So there's no code that you can execute Python because it was done for safety reason. But what I checked, there's like Sage and NumPy find a way to use like CPython libraries to interact with cache L1, L2, and basically to hash some operations. So maybe it can be good references for you at the beginning.
Okay, when does it make sense to manually trigger garbage collector?
When makes sense to trigger manually? I think maybe during caching, if you have a lot of caching and you don't have control of your caching and you don't want that your cache stays forever in your memory, maybe it's good way to trigger your garbage collection.
How Python manages cycle references?
Cycle differences. It's this one. Unfortunately, I don't. Cycle references. This I think so. Cycle references. I think it's when the object is get locked. So it's why I checked. I told them to check one of the previous talk pointers because it's very useful talk. It will talk about cycle references and when the Python objects get locked and it cannot be removed, and there are some kind of implementation libraries, improvement for garbage collectors that will build like craft, and it can help with cycle references.
Do you think Python could benefit from using pointers, not only for performance, but for being explicit in behavior and memory management? Do you think Python could benefit from using pointers, not only for performance, but being explicit in behavior and memory? It's very good questions, but also, unfortunately, I don't have answer for it, because really to understand what brings you performance, you need to compare. So you need to run tests, you need to run some performances tests, and after that, after measurement, you can really see what will help you. So it's very hard to say without real life example. Okay. When does a garbage collection run? In a separate CPython thread or as a step in a main loop?
Yeah. What does a garbage collections? When does a garbage collection in separate Python thread or step in the main loop? I think it's run behind the scene, but I remember, but maybe I'm being wrong, but unfortunately I don't have question for it. I know that it runs on the background, and also it was done so do not influence performance so much, but it's very hard to say in which thread it runs.
Okay. Which challenges have you experienced?
Yeah. Yeah.
Okay, I will read out first. Okay. Which challenges have you experienced that you had to dig into Python memory management?
Python memory management. Fortunately, so far, no zero challenge. No, it's not about Python memory management. It's more about optimizing your environment, because depends on the applications that you run. For example, in case you have a lot of operations, calculations, like a lot of operation for processing, you need to have stronger CPU. In case with communication of the data, and maybe bigger RAM memory. In case of the storing the data and reading from hard disk, you need to also to think about the quality of your hardware. So it's not only about like problems of the memory, but also think about where your Python get executed.
There is a last question. The talk summary mentions tools to analyze memory uses and optimization tips. Could you talk about some of these tools, please?
So there's memory profile, one of the native Python tools, and for beginning you can start to use it. And I think yesterday there was a nice workshop unfortunately it was yesterday, also for profiling. It was memory, I believe, and memory, yeah. And also a very nice tool for profiling all the memory, so you can check it.
Thank you so much.
Thank you.